This is partial differential equations, and before we can solve any partial differential equations, PDEs, we're going to have to learn to do Fourier series using the Fourier formula, Euler Fourier formula here. And to find the coefficients A0, AM, BM for this series, I'm going to multiply both sides by cosine of n pi x over L, and then integrate from negative L to L. So on the left, f of x cosine n pi x over L from negative L to L, negative L to L, A0 over 2 cosine n pi x over L, plus, I'm going to bring the integral inside the summation, integral from negative L to L of AM cosine m pi x over L cosine n pi x over L, plus the sum, m equals 1 to infinity again, integral negative L to L of Bm sine m pi x over L cosine n pi x over L, where this m and n here do not have to be the same value. So I have on the left the integral negative L to L f of x cosine n pi x over L dx equals A0 over 2. Integral of cosine is positive sine, and for my u substitution or reverse chain rule will give me L over n pi. N pi x over L from negative L to L. And for n not equal to, well, this only works for n not equal to 0, but for n, a non-zero integer, which I'm summing over integers from 1 to infinity, sine of n pi L over L will be sine of n pi, which is 0. Sine of n pi negative L over L is sine of negative n pi, which is also 0. So this term is 0. And then I have plus the sum, 1 to infinity, integral negative L to L, AM. And I have the cosine of one value times the cosine of another, which will be 1/2 the cosine of the difference plus the cosine of the sum. M minus n pi x over L plus cosine m plus n pi x over L. And I'll come back to the sine cosine term. Integrating these, I have the sum 1 to infinity AM over 2, combine the AM with the 1/2. Integral of cosine is still positive sine, so that would be L over m minus n pi sine m minus n pi x over L, negative L to L, and then plus the sum AM over 2 L over m plus n pi sine m plus n pi x over L, again from negative L to L. And I'll come back to my sine times cosine integrals later. But as happened here, this is sine m minus n pi L over L is 0. Sine m minus n pi times negative L over L is sine of negative some whole number times pi, which is 0. So this entire summation is 0 for m not equal to n. I'll come back to m equals n later. And this is 0 always. So this is only non-zero for m equals n. So that would be an over 2. And for m equals n, I have cosine m minus n pi x over L is cosine of 0, which is 1. Integral from negative L to L of an over 2. And the only thing I've left out is the summation of the sine times cosine. And the integral of an over 2 is the integral of a constant, which the integral is just the area under the curve. So this is the base times the height, the area of a rectangle. 2L times an over 2 is L times a sub n. Integral from negative L to L, f of x cosine n pi x over L dx. And then I need to find the integral of this b sub m sine m pi x over L cosine n pi x over L. And that's 1/2 the sine of the sum plus sine of the difference. So bm over 2 times sine m plus n pi x over L plus sine m minus n pi x over L. And I'm short on space. I'll squeeze it in here though. So I have bm over 2, and the integral of sine will be negative cosine, so I'll get negative L over m plus n pi cosine m plus n pi x over L. And over here, I'll again get bm over 2 L over, this time, m minus n pi and cosine m minus n pi x over L from negative L to L. Cosine m plus n pi L over L is cosine m plus n pi, which is positive if m plus n is even, negative if m plus n is odd, but in either case it's equal to the same value at x equals negative L, because cosine is an even function. So when I take the value at L and subtract the value at negative L, I'll get 0. And the same thing here. The whole thing simplifies to tell me that the integral from negative L to L of f of x cosine n pi x over L equals L times a sub n and that can be written to tell me that my a sub n coefficient is 1 over L times the integral from negative L to L f of x cosine n pi x over L. And that's the formula we'll use when we're finding Fourier series to find the a sub n coefficients.